It is also a type of electromagnetic radiation and is in the electromagnetic spectrum then. Light travels in straight lines and it travels as waves. As it travels, it transmits energy, so it is a form of energy. Our sun, which is a star, is a light source, just like a filament lamp or a firefly. What colour of light has the most energy, red or violet? Well, that one's red. And how do we see the planets? Well, the planets themselves don't transmit any light energy, but we can still see them. What they actually do is reflect the sun's light to us. So whenever the sun is transmitting its light, some of it is reflected by the planets to us here on Earth, and that's how we can see them in the sky. Next one, elastic energy. If you squash or compress an object or material, when you let go, some materials have the energy to return to their original shape. We think of like a spring. If you squash a spring, it will bounce back out to its original shape. We call the energy stored in a squashed or compressed material elastic potential energy. The same is true for materials that are stretched or put under tension. They too have the potential to return to their original shape, so they also store elastic energy or elastic potential energy. The final form of energy is nuclear energy. This is the energy stored in the nuclei of atoms. When nuclei are joined together or split apart, large amounts of energy are released. So nuclear fusion then, whenever we fuse something, it means to join together or stick together. So nuclear fusion is all about nuclei joining together. When atomic nuclei join together or fuse, it releases massive amounts of energy. And this is what happens in the sun. Nuclear fission, a fissure in the ground would be a split in the ground, if you remember your geography. So nuclear fission is all about nuclei being split. When atomic nuclei are split apart, it releases massive amounts of energy. And let's remember the nuclei, or the nucleus of an atom, is the very central core of it, which contains the protons and neutrons. So then to summarise nuclear energy in particular, nuclear energy is the energy stored in the nuclei or nucleus, singular, of atoms. When atomic nuclei join together, it is known as nuclear fusion. And when nuclei are split apart, it is known as nuclear fission. Nuclear fission powers nuclear power stations and atomic weapons. So this is the energy that we harness to produce electrical power in a nuclear power station. It's associated with nuclear fission. Nuclear fusion powers the sun and other stars. Okay, let's move on to a few questions. Just to finish off the forms of energy. What type of energy is stored in a coiled spring? Well, in this case, it's not sound nor kinetic, it's elastic potential. It's stored in a coiled spring. Which type of energy is stored in baked beans? Well, that's chemical energy. And what type of energy is stored in coal, oil and natural gas? They're all forms of chemical energy. Some questions about energy transfers then. What are the energy changes in these examples? An electric fire. Well, the clue's in the name, electric. We start with electrical energy and we convert it to heat. Number 2, what are the energy changes in a microphone? Well, this one can be a bit tricky for people. You need to think about what a microphone actually does. You speak into a microphone and it takes the sound energy associated with your voice and connects it to a loudspeaker, but the transfer within the microphone is actually sound to electrical. In the loudspeaker, it then converts electrical back to sound so that people can hear it. But the microphone itself is simply converting sound to electrical. Next one. These energy devices or examples have some more stages to them. A bulb in a circuit. So there are two aspects to it. So there's the bulb, there's the fact that it's in a circuit. Well, a circuit is usually connected to a battery. So we start with chemical energy, which is converted to electrical energy, which then is converted to light energy in the bulb. But we did say earlier that a bulb will have some heat associated with it. It heats up. So it's converted to light and heat. Number 4 is a more unusual application. It's using a steam engine to light a bulb. But this question is really about making you think about what's going on within an energy transfer device. Steam engine. Well, we start with chemical energy in the form of fuel. It then burns to produce heat, which heats water to form steam. That steam then rises. So there's gravitational potential energy. And when it rises away from the water, it moves up and turns a turbine. So the turning of the turbine forms kinetic energy. And within that turbine, the kinetic energy is converted to electrical, which is then converted to light within the bulb and heat. Now that's quite a long process within that one, but it does get you thinking about the exact energy transfers. We're starting with chemical converted to heat, which then converts to gravitational potential of the steam, which is then converted to kinetic when turning the turbine, which then converts that kinetic energy or rotational kinetic energy into electrical, and then the bulb takes the electrical energy and turns it into light with some heat also.